Hey guys, so let's talk about scientific notation some more. We know that if there is a positive exponent with the base 10, it's a really big number. If there's a negative exponent with the base 10, it's a really, really small number. We know that that number, the coefficient currently underlined in blue, always needs to be greater than 1 but less than 10. So, what happens if we're doing some problems and we get a final answer that looks like this? Is that coefficient, the thing that is at the front of the scientific notation, is that number greater than 1? Yes. Is it less than 10? Nope. So we need to adjust this number so that it is greater than 1 but less than 10. So obviously, you guys can tell the decimal needs to go right here. So my coefficient needs to look like this. Okay, here's where a little bit of the trick comes in though, because you can't just plop down a 10 to the fourth power since you've moved the decimal. You've actually changed what the number is when you switch the decimal, and that changed the place value. So you can't keep this power of 10 the same, because that's saying that nothing has changed about this, even though you change the place value. So it messes everything up if you keep that place value actually the same. Let me show you why. So we know that this number represents, I'm just going to throw a bunch of placeholders here so that you can see this happen. So the decimal was here, 1, 2, 3, 4. So this actually represents this number, agree? So 283,000. So even when I change the coefficient on this number, whatever the power of 10 is here, I shouldn't have used that, it looked like a 0. Whatever the power of 10 is that I put here in this weird amoeba, when I convert this final answer back to standard form, these numbers need to be equal to each other. I need to still get 283,000 regardless. So if I had brought down the power of 10 and kept it 10 to the power of 4, check it out. Decimal point is now here. I should try to put it here. Okay. If I move 10 places, 1, 2, 3, 4, right? That's not the same number, because this actually gives me, if you'll see, this actually gives me 28,300. Okay, so I cannot just plop down that power of 10, the fourth power. I think you can see pretty quickly, though, what needs to happen. So my goal number is still this 283,000. I need to make sure that stays the same. So if the decimal point started here, and you know that it actually, is living there in standard form, you need to see how many place values is that? 1, 2, 3, 4, 5. So this is the proper place for the decimal to live when we're talking scientific notation. You know that this is like its final resting place for standard form. So you just need to figure out, okay, how many shifts is that when I'm properly in scientific notation? And it is 5 place values. So you're going to have 10 to the power of 5. So if I got this as an answer, it looks pretty good. That's the correct answer, but it's not properly in scientific notation. So I have to do one extra step, and you saw that in the multiplication and division videos. I have to do one extra step so that it's properly in scientific notation. Let's look at an example where I have a negative exponent as my final answer. I'm going to keep using 28.3 because I love 28 and deal with it. Okay, let's say 10 to the negative fifth. So, you know, in standard form, I really should have taken this whole thing. I wonder if I can do this. Haha, I want it to go over here. So I am going to take this number and same thing like before. Okay, what is this number in standard form? So I'm going to start with my digits way over here because I know I'm going to be shifting the decimal to the left, making this a smaller number. It's not working for me. Okay, so the -5 tells me I need to shift 5 place values and make this number smaller. So from where the decimal was, I'm thinking 1, 2, 3, 4, 5. So this is the final resting place for my decimal. And then these other little bumps here, I just use zeros as placeholders. I don't love, again, when we say that we're adding zeros because mathematically, if I add 0, nothing changes. So I like to say that we're adding placeholders or putting in placeholders, something like that. I know it's a silly, nerdy thing, but that's what you get when you're working with me. Okay, so this number is this in standard form. So even if I change the decimal, because I know that the decimal actually needs to live here to be properly in scientific notation, even if the decimal goes here, my goal, my standard form number cannot be changed. So I know that it needs to be 2.83. It's going to be times 10 to the something. So here's how I think about this. I'm like, okay, it needs to end up here. And now I've put it here. So if it was here, let me think to myself, 1, 2, 3, 4. So it actually only shifted 4 places, making it, and it's a smaller number. So you're thinking it's a -4. So either way, the first example I kind of showed you a longer way. This way went a little bit faster, but I like to first, I always write out the standard form version of the number so that I know like what my goal number is. And then it also just helps me to be able to like check my spaces and know that I'm going in the correct direction and that I've correctly shifted my power up or down, depending. Sometimes you might have to shift a decimal more than one place. So let's just make a new problem here. Maybe you get an answer that looks like this. In which case, same idea. You know that the decimal needs to live right here. So your final answer would be this, and we'll talk about how many decimal places you should keep later. But if the decimal place shifted here, right, you would have to figure out that now that I've shifted that, notice that there's a change of 2 exponents here because I was shifting 2 places over. So sometimes that will happen. But again, I think that figuring out for yourself what the goal number is in standard form will help you not make a mistake with that. Again, I'm intentionally not giving you whoops, that's not what I wanted to do. I'm not giving you like when you move to the left, you go up with the exponent. When you move to the right, you go down with the exponent. Like I'm intentionally not doing that because I don't think it actually helps you make sense of what is happening with the numbers. Sorry, not sorry if that bothers you. You can go find other YouTube videos if you want those rules for yourself. But yeah, this is a video just helping you realize that sometimes you'll get a number that isn't exactly in scientific notation, and it is important that we convert it to the correct way of writing scientific notation before submitting your final answer.